All right, so it's recording. I'm going to share the screen. Okay, so we are now sharing. So let's go back to here. I'm going to create a new Jupyter notebook, right? So I'm just going to do new. Oh, and also for this, we're going to need data. Okay, so I already downloaded the data. So let me show you where it is. So you guys can go to the GitHub, right? And go to PyTorch, right? And in basics, click on basics. And you can see I've added this file. Sorry, I don't need to. Data.zip. So you're going to need that zip file, which has all the files that we're going to use today to just kind of read in. Okay, now to download something from PyTorch, from GitHub, if you don't remember, you have to go to the repo, actually. So in this case, you would go to PyTorch, and you click on this green button here. And then down here, it says download zip. Click on that. It'll download the whole thing, and then just copy the data.zip that you need. Does that make sense? Any questions on that one? All right, so that's basically the idea. Okay, so we can do that. Okay, so I'm going. All right, so we should be done with the GitHub part. So I already have it, so I'm gonna cheat. Just copy. That should be in section 2. Yeah, so I already have it here. Section 2. I'm gonna copy this data. Right, that file. I'm just gonna move it into the first section. Yep. So these are the files that we're gonna need. I double click. I've got a folder called image cats. All right, so we're gonna do that. Scifar 10, you can see that's downloading data from data sets. So that's another approach that we will explore. There's a file in there called Bobby, which I think is a dog or a cat. It's a dog, yeah, Bobby. And so we're gonna be reading in that image also. And we're gonna be reading in this file, this CSV file called wine quality. So sometimes data is, can be found as a .csv file. That's usually called tabular data. All right, and that's what we are going to play with. So that's what we're doing, right? Reading in data is actually one of the most challenging things that you will encounter when you have raw data and you have to convert it into a tensor that will fit into your machine learning model. So this is, important. So we're going to play with that today. And then finally, we're going to kind of wrap up, play with these pictures of cute cats, right? And so, just to kind of have some fun with images. All right. So let's go ahead and I know I'm sharing. Let's go to here. Yeah. So as you can see, I already have in here data. All right. This is the folder. You can click on it and you see all the files are there. Okay. So then I'm going to go back to the Jupyter, this area, and I'm going to create a new Jupyter notebook. And basically this one, as I said, will just be about reading in data. So we can even call it, let's add a few new cells here. And I'm going to rename it as read in data to PyTorch. All right, so we're going to read in data to PyTorch. You can click rename there. Add a few more cells. Now we are going to, there's a lot of libraries that can be used to read in images and files. Eventually, we're going to use pandas quite a bit. But for this example, we're going to start with basic stuff. We're going to need a library called image.io. And in the future, we're going to use PIL also to play with images. So a bunch of libraries for this. All right. So let's go ahead and grab we're going to be using torch tensors. So we want to go from either CSV files or image files into Torch tensors, right? So that's kind of what we want to do. So import Torch, import NumPy as NP, import OS. This will be useful for dealing with a file system and reading in files. So let's hit run there, and that should work fine. Okay, now image IO, I don't believe it's installed by default, so let's just see. So it should be import image IO. So I'm going to hit run here. So you can see it broke because it's not installed. So we already know how to install a library, right? So we just do exclamation pip install image IO, and hopefully that'll work. So hit run. Okay, so successfully installed. So now let's hit run here. And as you can see, no errors. So that means we have our library and it's all good. All right, so now we just need to know the path of where our file is. So our read-in data is here and our data is right there, right? So basically that's the path. So it's pretty easy. So then we're gonna read in our first image, which will be that Bobby.jpg file. It's a picture of a dog. So let's do img array. Okay, and we're going to read in using image IO for input output dot imread. Okay, and that's going to be in data. We're just going to call Bobby.jpg. Okay, and once we have that, we're just going to print out the shape. Remember, it's basically going to read in, possibly it's a NumPy array. And so that's the image ARR. So we can just do dot shape. And this, we're trying to become familiar with the shapes of things, right? So remember, everything is a tensor, an object. So think of it as a Rubik's cube, right? So everything is that. So we want to know the shape of it. So I'm going to hit run. And this tells me that the shape is 976, 1334, 3. So how do you interpret that when you look at it? Is it black and white or color? It's RGB, right? It's the color, the 3 channels, right? So that tells us that. Now, PyTorch has very specific things for some of its models. It wants images to be in a specific order, all right? And the order, so I'm just going to write this down. So I'm going to say PyTorch. So PyTorch requires images like this, right? So PyTorch wants images to be tensors where the first thing is the channel. The first dimension is channel, then that's going to be followed by the height, and then that's going to be followed by the width. It should be height and width, like that. You see that? But our image does not follow that format, right? Our image is probably height, width, channel, instead of being channel, height, width. So a lot of algorithms expect things to be in that way. So what we can do is, we're going to convert this array into from NumPy into Torch, and then we're going to use a function called permute to kind of change the order, and that should be pretty straightforward. So the way we can do that is I'm going to take img, I'm going to invoke Torch, and I'm going to say from NumPy. This is a function we have seen before. So from NumPy, right, we're going to call image ARR, right? And so now we know it's a torch tensor, right? So it's become a torch tensor. And now we're going to go ahead and change the image. So I'm going to say img dot, and then we can call a function from torch called permute. Very convenient little function. And this will just allow us to make height width channel into channel height width. And that solves the problem. All right, so all we need to do is do a little bit of indexing. So basically we're gonna say height is 0, 1 is width, and channel is 2. 0, 1, 2, right? So we just have to change that order to be dot 1 0. Do you see that? So we're basically moving the 2, which was at the end, like this, right? That's height width channel. So we're saying we want the channel to be in the front. And then we have the color. Okay? And then we can corroborate that by printing the shape again. So we run this. Oh, did I put a comma? Get rid of that comma. Hit run. Okay, and now we can print out the shape of image again. So I'm going to do print img.shape, and hopefully, yeah, you see it's now channel height width. Got it? And like I said, that's just a PyTorch convention. That's what it was. Okay. Any questions? All right. So the next example that we're going to look at is to create something that's going to be very common. Is a tensor that is a batch. All right. So the definition of a batch is basically is when we give it several inputs. You know, we give the model several inputs at a time. That's a batch. So for instance, in the previous example where we did Celsius to Fahrenheit, if we gave it 6 Celsius values, right, that would be a batch of 6 of our sample. So in this case, we're going to use the cat images in the folder image cats. So if we go back to GitHub and click on base, oh, actually, I can just do it here. If we go here, right, to data, this folder contains 3 images of cats. Do you see that? So we got 3 images. I'm only going to use these 3. And so I guess we can use them. But we take these 3 images basically, and we're going to load them into a tensor. Okay? We're going to load them into a tensor. That involves quite a bit. Got it? We're going from a folder in the local system, the file system, to a tensor in memory. Let's go ahead and try to do that. Uh, 201. Yeah, that's actually, yeah, you're right. Yeah. Because that's how it was, right? So 0, 1, 2, and then we just move the 2. Yeah, you're right. Good catch. That's right. So I probably then was printing, and it was reflected, right? I moved the 976 to here and the 1334 to B4. So I did. Yeah, good catch. Make sense? All right, perfect. Good. So now yeah, we can run it again. And you'll see that it changes a little bit. All right, so now let's do the other one. As I said, we're going to create a batch. We have 3 images. So let's just say that the batch size will be 3. So we're going to specify batch size equal 3. And then I can create this tensor already before loading the images, right? So remember, we're just playing with, you know, tensors, just like we did with NumPy arrays, etc. So here I'm just going to do .torch .zeros, right? And now I need to specify the dimensions of this tensor and the data type. So the values are integer, right? Because they just go from 0 to 256. They're RGB. So that's easy enough. We can say, we've already seen this data type equal, and we can pick one of the types. So for instance, torch dot uint 8. All right, and that should be able to hold values from 0 to 255. Okay, you can always look this up, and it'll specify online what what it is. All right, now the dimensions of this tensor. So this tensor actually, we need to know several things, right? First of all, the dimensions of the cat images, right? So these are different from this Bobby image. This Bobby image was really big, right? It was 974 by 1334. Those three cat images are smaller. I know for a fact that they are 256 by 256, okay? So I know that, and they are in color, so they will have the 3 channels. And then the tensor is a 4-dimensional tensor, which has this dimension of samples. It's like one image, and another image. So there's 3. Just keep in mind, these images are 256 by 256, and they have 3 channels, okay? So we're going to build this tensor, so we can start with batch size. Batch size. Comma, that's 3. Then PyTorch wants the channel to go first. So that's 3 here, right? Then 256 by 256, because I already know they are square images, and 256 by 256. All right, so that's my my tensor. We can print the shape of that just to kind of see it. So I'm gonna, it's basically made up of zeros right now. But we can add the data later. Did I miss a comma? Yes. Okay. Comma. All right, so let's try it again. And there you go. So this is 3 by 3 by 256 by 256, right? Because the first 3 is just 3 images. All right, so we know we've created the tensor. Now what we have, and it's a batch tensor. Now what we need to do is we need to add the 3 images from memory into this tensor. Okay, so we're going to specify the location of the images first, so we can create a full a path, and I'm going to call it data directory, data underscore dir, and that's the path is basically data. And it's the folder called image dash cats. Okay, that's where my cats are located. All right, then the next thing I want to do is I'm going to read in the file names into a list. Okay, so I'm going to create a list called file names. I'm going to use the list comprehension. I'm going to basically use list dir. List dir. Okay, and I just need to specify the path. So this is a function. So I'm gonna data dir, right, like that, and that will return a list of the files. So actually there's 4 in there, but I just want 3 of them. Okay, so keep that in mind. So I'm gonna iterate through this list through a list comprehension approach. So I'm just gonna say for f name in this list, and then I'm gonna add f name to this list. Okay, so now that I've done that, I can print file names. And as you can see, I have the 4 files in there. However, I have a problem. I only want 3 of those, right? I only want the PNGs. I don't really want the JPEG. No. What can we do here? There's a couple of tricks. Any questions on the list comprehension before I continue? Guys? No questions? All right, so I'm going to add an if statement here just to kind of tell it that I only want files that end with a PNG and not with a JPEG, okay? So the way that you can do that with a list comprehension is just to add an if statement here. I'm going to use os.path.split text. So for each file, it should split on the dot, right? So split this by default, split text of F name. You see that? So as I'm iterating through every file and I'm grabbing F name, I'm going to actually split it on dot by default, and that will give me a list for each file of the name and the extension. Do you see that? So then I just need to grab the extension, which is by indexing square bracket, and I want the last one, so that would be -1. Do you see that? So now for each file, I have it after the split by dot, the extension. And so all I have to say is if it's equal to what? PNG, right? So it should be maybe PNG. Let's see if it works. All right, so that should be it. So this should get rid of that file because it's a JPEG. Nope. What was path? Oh, okay, split text. Sorry, split text. There we go. Do you see that, guys? Don't worry about this if it looks confusing. You know, this is not. It's kind of the trick, right? But basically, it's a quick way. You could have done it in other ways. This is just a quick way within this list comprehension. If you haven't used list comprehensions before, I do recommend take a look at them. They're very useful. But what you can see here is that now we were able to grab just the 3 PNG files, right? And we're ignoring the JPEG file. Any questions? The colon to limit the size? Yeah, I think I get what you're saying. Are you saying :3 like that? And that works? You tried it? Okay, perfect. Yeah. Yeah, so it's a type of a slicing or indexing. Very good. Nice. All right, so yeah, so we have our 3 files, right? So now what do we want to do? Now that we have them, we just want to read them in. Okay, so we're going to have a for loop. So for, now in this case, I'm going to, what do I want to do? Yeah, I'm going to need an index. So the batch holds 3 values, right? Which is 3 images. So that's going to be 0, 1, and 2 for the very first dimension. Okay. So I may want to index, have an index. So what I can do is I can enumerate file names. So when I enumerate file names, when I use the function enumerate file names, it'll iterate through that list. It'll give me the value in the list, but it also gives me the index very conveniently. So I can do something like for I file name in enumerate. Do you guys see that? So this is really nice because not only do I have the file name, but I know the corresponding index, and then I can use that as I'm operating. So for instance, if I have the middle file name, I'll have an index of 1. All right, so now we're all set. We can just go in here. I'm going to add indentation. Of course, 1, 2, 3, 4. Image array, similar to what we did before. I'm going to use image io dot IamRead. And I'm going to read in the image. So I can do this a couple of ways. One way is to continue using os path dot join, and we can join here two things. The data dir, right, which is this here, data image cats, this path, and the file name. So it'll just add the file name at the end. So comma, file name. Do you guys see that? And that just gives me the full path to the image. And now I can read it. And then once I've read the image, what do I need to do? I'm reading it as a numpy, so I need to convert it to torch. Then what else do I need to do? We know that it's reading it not in the order that torch wants, so we have to permute. And then after that, we just add it to the batch. Any questions? All right, so let's do that. So I've got the image. Now I'm going to do image, but I'm going to use that convention where I say that now it's a torch tensor. So I'm going to call torch dot from numpy, open parentheses, close parentheses. And now I'm going to do image R, right? Image array. And then now it's a torch tensor, so I can use the previous example. Image T equal image T dot permute, right? And permute, what were the values here? 2, 0, 1, right? So we permute it. And the last part should be batch I, right? So here's that where that index comes in. So we're going to say 0, 1, and 2. We're going to load the image. Got it? Remember that the batch is 3 by 3 by 256 by 256. Do you guys see that? That's the batch. The images are what currently? 3 by 256 by 256. Do you see that? So they'll fit in here. And the index just controls if it's image 1, 2, or 3. So when we say image 0, we're taking the first image and loading it into the section that is 3 by 256 by 256. When we grab the second image, this is 1, and we just load it into the section that is 3 by 256 by 256. When we grab the last image, that's going to be 0, 1, 2, so that's index 2, and we load the whole image into this section that holds 3 by 256 by 256. Got it? As long as it fits, it does not care, right? All right, so now we can go ahead and do that. Batch I will take image T. And just like that, hopefully we have data now. So let's go ahead and run it. Okay, doesn't like it. File name is not defined. Oh, it's file names here. Yeah. File name. So let's try it again. Okay. No, I think it worked. I think it worked. It's just that we're not displaying anything. How do we know that it worked? Initially, our batch had zeros, right? So now what would we expect? We would expect that batch should contain values in it. So the name is batch. So how about we just print batch, and there should be some values in there. What do you guys think? Did it work or no? It didn't work. No.
Second line file in the code.
Uh-huh.
Second line.
It didn't work? What do you mean the second line?
The file name. One.
Which part?
One.
This you mean?
Yeah.
This should be file name, not file names, because file names is the list of all the, and then we iterate through it, and every iteration we're grabbing just one file name, reading it in and adding it to the tensor batch. And then once we finish, we've got this. So if you guys look at this, how do you interpret that? The tensor is no longer zeros, right? Instead, it's actual values. We've loaded the data. Guys, any questions over there?
No.
Yeah.
Yeah.
Are you guys stuck somewhere?
I'm getting all zeros.
You're still getting zeros. You need to add image T. into batch I. Go ahead, what, yeah, got it?
For some reason the file, the path to it, above, it gives me all the file names, but then when I use the image or the read in, it's giving me the whole path, just the first letter of the file.
Where? So in the, are you talking about up here?
No, I got all that, that's fine. It's
Okay.
in,
When you print, you get these three?
yes,
Okay, so then you are using enumerate?
yes, I am,
Okay, so then enumerate over file names, correct?
correct,
Plural.
Correct.
Okay, so that should give you, that should be this list here.
correct,
So now for I comma file name, singular.
Correct.
In enumerate file names.
Correct.
Okay, so every iteration is just, so the first one he just grabs cat1 PNG and index 0. The next iteration, cat2 PNG and index 1. The last iteration, cat3 PNG index 2. So then here you do OS path join data dir and file name, singular.
have all of that, but it's just grabbing the first letter of the file.
All right, let me take a look.